Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, everyone.
Afternoon, sir.
Afternoon, sir.
Are you fine today?
Yes, sir.
Yes.
Anyone absent today in 10B?
Ready, sir.
Everyone is here, right? Okay. As usual, before we start our lesson, let's pray. Pray begin. Amin. Okay, let's see now. 14 students already here in the Zoom. Okay. 19 students in this classroom, isn't it? Okay. So as usual, please fill the attendance. I'm going to send also the link to the chat room. Please, you can reach the link from the chat room. Okay, while you are filling the attendance, let me share my screen. Please don't mind if I turn off my video. Just when the video is open, I couldn't write in my presentation. So that's why, please don't mind, I have to turn off my video. Okay, so I can write in my presentation. Did you see the slide now?
Yes, sir.
Yes, sir.
Right, this comes to lesson number 19 in the conference September 1st, 2020. So still we are going to continue to discuss about the modern atomic theories. Okay, last lesson we finished actually the theories. Now we came to the quantum numbers today. Okay, before we start, let's make a quick review about what we did last lesson. Okay, let me ask one student. Let me check from the list first. Muhammad Rizky Awali.
Yes, sir.
Okay, are you here, Rizky Awali? Rizky Awali, let's review what you understood from the last lesson. Let's make some quick review. What you learned from last lesson?
Wait, sir.
Okay. I hope all of you have your notebook, right? So when I'm talking here, you're taking note.
About quantum number, sir.
Okay, before quantum number, what we learned? Okay, let's see another student. Okay, Helga Latif Martiza. Helga, what you understood from last lesson? What you learned? Are you here, Helga? Helga? Helga is not here?
Mungkin lag ya Pak. Sir, he's lagging maybe.
Okay, then another student, M. Irfan Wira, M. Irfan Wira Kusuma. Yes, Irfan. What did you learn from last lesson?
About modern atomic model and quantum numbers.
Yeah, before quantum number, what you learn? That's one important thing here. Before we learn quantum numbers.
Schrodinger's.
Okay, Schrödinger about the probability of anything. Remember what is the name of the place where we probably okay. Is ini Adnan?
Yes, sir.
Remember what we learned about the place where we probably find the electron?
Probably region,
Yes.
orbital, maybe.
What we call? It is
Orbital.
orbital. Good.
Orbital.
Okay.
Orbital.
Okay. It is about orbitals. Tell me more about this orbital. It is what?
It is a probable region where maybe we can find the electrons and also quantum numbers.
There's a place. Places
Where electrons should be.
we probably
no
find,
where electron probably be in there.
find the electron, isn't it?
Yes. Yes.
Okay. Now we have also one concept we call as an orbit. What is the difference between orbital and orbits?
Orbit is the apa kayak anunya tuh jalur
Lintasan jalurnya apa itu?
ya lintasan apa bahasa Inggrisnya?
Okay, one
Ya,
student.
bisa apa?
Robi Andika Pardede. What is orbit? Robi?
Yes, sir.
What is orbit?
May I tell it in bahasa or
Yes. Okay, you can use bahasa.
Orbit itu lintasan nih yang memiliki jalur yang bentuknya melingkar, tidak mesti bulat, bisa elips.
Okay,
It's like
path for electron to move, isn't it?
yes.
Okay, good. So orbit and orbital are different. So how you will find the orbital?
In empty spaces between
Where? I'm asking you how to find the orbital. What should you know to find the orbitals?
probability.
What?
Probability.
Probability is orbital itself is a place where probably find the electron. But how to find this orbital? How do you have to know? What things that you have to know to find orbitals? We're talking about numbers. What's that?
Quantum number.
Yes, it must be what?
Quantum number.
To find
Quantum
the
number.
orbital, you have to know the quantum numbers. In daily life, the quantum numbers is like what?
It's like address.
Yes, like an address.
Address.
Good. So if you know the address of something, then you can find, isn't it? So it is like that. If you want to find the orbital, then you have to know the quantum numbers in order to find the place of the orbital. If you can find the orbital, then you can find the electron. Probably, because your probable region of something or electron can be found is, we call it an orbital. So if you know the electron, then we can know the behavior of the atoms. So this is our key point, right? So last lesson we stopped in here. We're talking about orbital mostly last lesson, and we start a little bit about quantum numbers. Today we are going to see in detail about this quantum number. Okay, let's start then. Let's see the quantum number in detail. So this is quantum numbers. Yeah, it is a specify the address. Like I told you that it is actually an address of each electron. Remember, this is not an address of an atom. This is electron. Yeah, an electron is in the atom, isn't it? Electron is in the atom. So if you know the electron, then automatically you can know the if you know the electron, automatically you will know the atoms. And we say that there are 4 types of quantum number. Anyone remember what is the four type of quantum number? Anyone remember?
Yang kuantum utama itu
Yes.
Main quantum,
azimut,
Azimut.
azimut, habis itu apa lagi yang magnetic, magnetic lawan spin,
Magnetic.
bilangan spin.
Spin.
Okay, we have 4.
Spin.
It is principal quantum number, or it's not main quantum number. Yeah, in bahasa it's quantum bilangan quantum utama, but it's principal quantum number. The second one, azimuth, in bahasa we call this one, but in English sometimes it's called a secondary quantum number, or it's the same as azimuth quantum number. But I prefer this word, it's easier to remember, secondary quantum number. And the third one is magnetic quantum number. The last one is spin quantum number. So those 4 is like an address. Yeah, those 4 is like an address. If you know that, if we want to find a place, then if you know only one of the address, it's not enough. For example, if you want to find a house, then you have to know what is the name of the street, what is the name of the complex or the site, what is the name or the number of the block, and what is the number of the house itself. So actually, those things must be known at the same time so you can find the address. So the same things here, to know the exact position of the electron, the probable exact position of the electron, then you have to know these 4 quantum number at the same time. Okay, it is clear? Can we move?
Oh, wait, sir. I want to write it.
Okay, please ask if you have any question.
Sir.
If you have difficulty, you can use bahasa.
Yes, sir. I want to ask, sir.
Yeah, please.
What is spin type of electron?
What?
What is spin type of electron? Do the electron spin while orbiting the nucleus?
Yes, that's true. The electron is spinning when it's orbiting the nucleus. Okay? Okay, is it clear?
Yes, sir.
Okay, any other question? No, can we move? Yes, can we move?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
Yes,
move that.
sir.
Okay, we are going to now see one by one about the quantum numbers. We are going to start with the principal quantum number here. I have to change my color here because it's white. Principal quantum number is denoted by n. Actually, this principal quantum number show you the shell or energy level. Remember? Who tell about this? Which scientists tell about this? Energy level in shell.
More.
It is by Bohr's, isn't it? So remember what Bohr's is talking about an energy level in shell. And remember we have the number N1, N2, N3, N4, N1, N2, N3, N4. So it is what show you the energy level of shell. Or sometimes we can use a letter for this, like K, isn't it? L, M, N. Remember this?
Yes, sir.
This one, yes. So this is what? This is actually the quantum number. And the quantum number for this one we call as the principal quantum number. Yeah, it's called as a principal quantum number. It's described what? It is described the size and the energy. We know that when it is n equal to 1, the energy is the lower energy. Okay, when n is equal to 2, the energy is increasing. N equal to 3, higher energy. N equal to 4, higher energy. And the same thing like size. Size also the same. When n equal to 1, the size is very small. Small, yeah. N equal to 2, getting bigger, the size. N equal to 3, getting bigger. So when the principal quantum number is increasing from 1, 2, 3, 4, the size also will be increasing and the energy also will be increasing. Okay? Is it clear? Principal quantum number, can we move? Any question about this?
No.
Okay.
Sir.
Let's move to the second one. The second one we call as a secondary quantum number. So secondary quantum number, it is denoted by a letter L, but it is small l, not a capital L. Okay. And it is called as a subshell. It is show you the subshell or sublevel. So subshell is new terminology for you. We know already shell. Yeah. We know already shell. Shell is an energy level where the electron is spinning or orbiting. And actually, inside this shell, there is also subshell. Yeah. After shell, we have also subshell inside. And the subshell is can be known by this secondary quantum number. Okay. Subshell has a name. For example, subshell can be S, subshell can be P, subshell can be D, subshell can be F. So we have 4 subshell up to now, S, P, D, F. And in a quantum number, because quantum number is talking about number, so it is not will be shown as SPDF, but it will be shown as a number. When L, which is the quantum, a secondary quantum number, is 0, it means it is S. When L equal to 1, it means it is P. When L equal to 2, it means it is D. When L equal to 3, it means it is F. Up to now, we have only 4 subshell, SPDF. No other subshell have been found, but it is growing. Maybe in the future, we will have another subshell, okay? but the subshell will be interpreted by numbers 0, 1, 2, and 3. What actually the subshell? The subshell is actually describe the shape of the orbital. Actually, the subshell is describing the shape, bentuk ya, the shape of the orbital. When we're talking about as, when the subshell is as, the shape will be like this. You have to think this shape of the orbital three-dimensionally, tiga dimensi ya. So as is like a ball, X, Y, Z plan pada apa? Plan S X, Y, Z. So it is like a ball, the shape of the S orbital. If we have orbital P, the shape is like this. If we have orbital F, the shape is like this. When we have orbital F, so it is a little bit complicated for F. The shape is getting more complex. So the F is like that, the shape of the orbital. Okay, it is clear. We have subshell. Subshell can be S, P, D, F, and it is denoted by number L0, L1, L2, and L3. And it is described the shape of the orbital. The shape is like this. I couldn't explain the shape, but you can see here the shape. Okay, and what is the correlation between this subshell with the shell? Okay, in n equal to 1, what does it mean n equal to 1?
Ke satu.
Yes, in the first shell.
First shell.
It is in the first shell. In this first shell, we can only have L equal to 0. What does it mean L equal to 0?
Satu S.
It is only S orbital which is possible in n equal to 1. In n equal to 2, we have 2 orbital possible, S and P. In equal to 3, it is possible as P, D. In n equal to 4, it is possible as P, D, F. So totally, if n equal to 1, only 1 orbital, n equal to 2, 2 type of orbital, n equal to 3, 3 type of orbital, and n equal to 4, it is 4 type of orbital.
Sir.
Yes, please.
What happen if n equal to 5?
In n equal to 5, now we are talking up to n equal to 4. Yeah, when n equal to 5, then only 0, 1, 2, 3 now exists. But actually, there are another orbital which is haven't been found. Okay. So if 5 now, it is the known orbital is only 0, 1, 2, 3, because we haven't found the 4th orbital. But it's still growing. Maybe in the future there will be L equal to 4. Who knows? Okay.
Sir.
Yes.
I still don't get it, sir. What is the connection between the primary and secondary quantum numbers?
Of course, there is connection. Let's go back here. In here, there is a primary quantum number, right? In primary quantum number, there is shell here, isn't it?
Yes, sir.
In the shell here, there are subshell here. In the shell here, there are subshell. Inside the shell, there is subshell. For example, in n equal to 1, it means that in the shell number 1, how many subshell possible?
1.
Only 1, which is
1.
So in the shell number 1 here, only 1 subshell possible, which is S. In n equal to 2 in here, n equal to 2 here, n equal to 2. How many subshell possible here?
2.
2. It can be S subshell.
S and P.
and P subshell. Now, inside the subshell here, there will be what? Orbital. We call that one S orbital, and P orbital, D orbital, and F orbital.
Sir,
Yeah.
so the secondary quantum number, it's more like orbital or orbit.
No, orbit and orbital are different. It's not orbit. Orbit are different. We are talking about orbital.
Secondary quantum number is like the house, maybe.
Secondary, no.
Kayak
Secondary quantum number showing you the shape, bentuknya, the shape of the orbital. So if I tell you that the secondary quantum number is S, you will understand that the shape is like this. If I'm showing you, telling you that the secondary quantum number is P, then the shape is like this. If I'm telling you that the secondary quantum number is D, then the shape is like this. If I'm telling you this, secondary quantum numbers is F, then the shape is like this. So secondary quantum numbers show you the subshell, actually the subshell SPDF. SPDF is the subshell, but in the subshell there are orbital, and the orbital have the shape, yeah, and the shape is like this, like in the picture here. Okay.
What shape it is, sir?
This is the shape of the orbital.
It's more like the shape of an electron, sir.
No. One by one. Okay. This is not the shape of the electron. No. The shape of orbital. Let's back. What is orbital?
Orbital, it's where
where electrons are in.
Yes.
Probably exist.
A place where the electron can be found.
Wow.
That's why. So in here, in this orbital, you probably can find the electron. In this orbital, you can probably find the electron, and so on. Okay. Next question.
Can I use bahasa
Yes.
for asking this one?
Yes.
Jumlah kulit maksimal satu atom itu berapa gedang, Pak? Sampai berapa
Now,
M itu? 7.
Yes.
Yes, sir. Jadi jika sudah lewat 4 tuh SPDF jalan.
Yes. Up to now only
sampai 7 SPDF-nya.
It's still growing, of course. Maybe in the future it can be found. Okay. Any other?
Sir, can I ask?
Yes.
Can I use bahasa?
Yes.
Berarti kita menemukan elektronnya tuh di merah-merahnya tuh.
Yes. Probable.
Di merah-merahnya.
Yes, probable.
Kemungkinan.
Okay.
Oh ya.
Okay. Another question? Clear?
Yes, sir.
Okay. We move. Okay. Now we move to the next one, magnetic quantum number. Okay. Now what magnetic quantum number? Magnetic quantum number, it is denoted by small m, and there is a subscript L. L also small here. So small m and small l. Okay. This number will give you an exact position, not an exact position, an exact orbital. Why this exact orbital? Why we are going to find the exact orbital? Because in a subshell, sometimes we can have more than one orbital. For example, if I have L equal to 0, what does it mean L equal to 0? Which orbital we have?
S.
S. Kamu beruntung. If it is S, it is very easy because S only have one orbital. Okay? If S is very easy because S is only one orbital, which is this one. So sudah pasti ini, the exact orbital is this one. Exactly, because it's only one. And the value of the magnetic quantum number for this is 0. Ya, nilainya ini hanya angka ya. The number for showing this exact orbital is 0. For S is easy, but there will be a problem if we have L equal to 1. What does it mean L equal to 1?
P.
SP.
SNP.
Equal to 1 is showing you P, isn't it?
P.
Now, if it is P, P is not one orbital only. P have more than one orbital, which is 3 orbital. P can be like this, Px, can be Py, can be Pz. Okay, ada 3 jadinya. We have 3 orbital. And that's why the number of magnetic quantum number for P can be 3. It is -1, 0, +1. How do you know this number? It's very easy. If P equal to 1 and L equal to 1, then the value will be from -L to +L, including 0. Jadi, if I have P is L equal to 1. Berapa orbitalnya? How many orbital? It must be 3, because it is starting from -L to +L, and including 0. So -1, 0, +1. Okay, and the shape is like this. This is the name will be Px, Py, Pz. Yeah, Px, Py, Pz. If L equal to 2, it is which subshell? Subshell berapa? Apa ini?
N.
D.
In D, because L equal to 2, then according to this one, -L to L, including 0, so there will be 5 orbital, -2, -1, 0, +1, +2. The shape is like this, yeah? We have 5. It is dxz, dyz, dxy, dxz, dx square, y square, and dz square. You can see from your book later the shape of this one. But there will be 5 now. And if L equal to 3, it is F, then there will be how many orbital? 7. Starting from -2.
7. 7. 7.
And the shape is like this. You can see from the picture here. This picture also available in your book. You can see this picture on your book. Ini sampai F. Later on, for example, if I have L equal to 4, imagine that in the future we have L equal to 4. What will be the ML? What do you think? How many?
The orbital will be 9.
It must be 9. Starting from -4, -3, -2, -1, 0, +1, +2, +3, and +4. But it is not found yet. Ini belum ditemukan. Tapi we can predict that if there is another subshell with subshell 4, L equal to 4, then there will be 9 orbital here. Okay? So this is magnetic quantum number. It is clear? So this magnetic quantum number showing you the number of the orientation actually. Orientation is what? Orientasinya. Because it can be more than one orbital. Karena lebih dari satu orbital, maka orientasinya yang mana? This one, this one, this one. We have different orbital. This orbital, this orbital, or this orbital. If it is -1, then this is this. If it is 0, then it is this orbital. If it is +1, then this is this orbital. So this orientation mean that one. Orientation mean orientasinya yang mana? Orbital yang mana? Which orbital is the orientation? Okay. If -2, then this one. -1, then this one. So there are 5 possibility for the orientation. For D equal to L equal to 2. For L equal to 3, there are 5 possibility of orientation. Ada 5 kemungkinan orientasinya. So which one? So which one will be knowing by the magnetic quantum number? Okay?
Jadi kayak kemungkinan bentuknya tuh apa?
Yes.
Jadinya makin ganal anunya, makin banyak tipenya kayak itu.
Yes. Bentuk.
Itu berarti bentuknya disuruh milih atau gimana itu?
No, not milih.
Ya, kemungkinan salah satu probability gitu ya, Chan.
Cara tahunya gimana?
One of them. We are talking about probability. So if L equal to 3, kemungkinannya ada 5. Ada 7. If L equal to 3, we have 7 possibility to have the electron found in the orbital. 7 orbital are possible. But if L equal to 0, only 1 orbital is possible. Okay? Is it clear?
Yes.
Okay,
Clear,
let's
sir.
continue to the last one. So up to now we learn about this. We learn about the shell, where the shell is containing also subshell, and in the subshell there is orbital, and we know that which orbital we have the orientation based on the probability of the place, right? So if you know already the probability, actually you know already the house. Rumahnya udah ketemu sebenarnya. You know already the orbital, isn't it? Dari shell, from shell, and then you can found the subshell. After you found the subshell, you found the orbital. Kemungkinannya, the probability you find the orbital, and the orbital is like the house, isn't it? It is the place where the electron might be found, where the electron probably found. Okay?
Like the shape of the house maybe, or the number of the house.
Yes.
So orbitals are like that.
Orbital, actually, you know already the house exactly. So this is the house. So this is the orbital. Okay? So if I know the orbital, I can think that inside the orbital, there will be what?
Electrons.
Electron.
There will be electron. Good. But the next one, we have another spin quantum number that will make me make sure. The next quantum number we're gonna spin quantum number. Actually, the spin quantum number is different things. Spin quantum number is only talking about the spinning. Do you know spinning? Berputar ya?
Perputaran.
Yes. So there will be two spinning. Either it is clockwise or it is counterclockwise. Searah jarum jam atau berlawanan. If it is clockwise, the value of spin quantum number will be plus half. If it is counterclockwise, the value of spin quantum number will be minus half. So we have two value of ms. It is denoted by small m and s here. The value only 2, which is half and minus half. If it is half, it is spinning clockwise. It's minus half, it is spinning counterclockwise. Okay? So actually spin quantum number is not talking about the place. It is talking about the spinning. Is it clear?
How do we know if the spin is plus half or minus a half?
You will not know, you will be given.
Oh.
Okay? We are talking about the probability. Okay? Is there any other question? Okay, if there's no other question, I think that's enough for today because the time also now already less than 1 minute. So in general, we are talking about the quantum number today. So in the second hour, we are going to go in the Google Classroom, and then there will be also process about this topic. Okay, from me for today is enough. Thank you for your active cooperation for today. It's good, yeah. Please ask question if you don't understand. Thank you. See you next lesson. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Warahmatullahi wabarakatuh.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.